Welcome. Today's talk is in English. I'm very happy to welcome Kas Oosterhuis. Kas Oosterhuis is an architect. Also in his recent bio, he doesn't name himself architect, but I remember you as a very well-known and interesting architect. He's also emeritus professor at TU Delft and founder of the Hyperbody Group of TU Delft. He leads the innovation studio ONL, Oosterhuis Leonard, and he runs this innovation studio with his partner in life and business, Ilona Leonard.
Leonard.
Ilona
Leonard.
She is here. She's an artist, so also very interesting work. If you are interested, you can look her up. And the leading research themes at Hyperbody were complex, non-standard geometry, interactive architecture, and robotics. At this point, I have to say that when I was a student, and I was here at your age in these lectures, I was super fascinated from the work that Kas Oosterhuis started probably at the time at the TU Delft because it was so new. And it's really a fusion of art, architecture, and geometry on a digital platform. So what I liked and what you probably will see today is that he can combine the architecture with new technologies. He has, for example, developed a unique and cost-efficient digital file-to-factory method that links parametric design directly to the CNC production and the assembly of the constituting components. Since his professorship at TU Delft, he has been traveling, working around the globe. He was 4 years a professor at the Qatar University, 2 years a professor at Qatar University, and then another 2 years he had a professorship in Bangkok at the Chulalongkorn.
Yes.
At the Chulalongkorn University. He has also many interesting built projects. One of them is the saltwater pavilion, the Web of North England, the Balna Mixed-Use Cultural Center in Budapest, and the Liebe Tower in Abu Dhabi. He is also, besides being an educator, an architect, an innovator, and a designer, he is also a writer. And he brought his newest books. He has written a number of books, but this is his latest book, and you will probably mention it.
Yes.
So, but I will give it, and you can have a look at it. I'm very happy to have you here. Welcome.
Okay, thank you. So let me check if you can hear me. Is that okay? This should be working. Okay?
That's good.
Down there? Yes? Okay then. But you don't hear it. Okay. Well, thanks for the introduction, Sandra. Thanks for inviting me. I think I will try to focus more on the title of this lecture, how to move forward, not looking backward, but inevitably I have to look back to get you acquainted with some of our works, and especially our realized work. I don't want to be speculative, like how a world could be, but actually use technologies that are available to make the world a better place, so to say, and especially how to be radical. How to be radical using very simple rules that lead to a situation that could be beneficial. That's what I am hoping for, at least, to communicate with you. Otherwise, during the lecture you can interrupt if you want. If you have a question, you can ask directly. Then the lecture will take longer, or I don't finish it at all. That's possible, but the feedback is more important. And also Sandra told me that's what she likes to do. So let's move forward, and let's see if, yeah. So this is the book. The book is full of QR codes. I don't have illustrations, but only QR codes, 800 plus QR codes they lead to interviews, videos, images, a lot of other interesting stuff. And it also leads to this page of the website. So let's start with featured projects that have been well published, most of them, but just to refresh the memory. This was started 40 years ago. That was my thesis project. I experimented with the idea that a simple rule could have a very strong effect. And you will see later that's actually what we try to do in the building business as well. Simple rules that create complexity. Not complicated, but complex, which is a different thing that actually is based on simple rules. So I imagined a strip over Holland that would be a law, actually. It would be wie sagt man, een Gesetz, a law that has not the shape of Holland, but has its own shape, has its own autonomy. So that tells you about the autonomy of design decisions. They are not necessarily depending on something else like the shape of Holland. So it could have its own shape. It could travel across all rivers and all other situations, and that's what it says here. If you can read Dutch, the first proposal was to build everything that is new inside that strip. So imagine what would happen if this was a law, that you could build only there, and the rest would actually be as it is, or renovated, or kept alive somehow, or become nature. So that's the idea. And then this would be quite exciting in a way to travel the strip and see everything that happens. And it would be quite exciting to have the difference between inside the strip and outside the strip. It would be a very big contrast. Creating contrast was one of the main purposes, radicality. That is radically different, yet very normal in a way. So the title of the book, it disappeared, is Personal Odyssey Towards Another Normal. So the things I am showing you, I consider normal, but for many of you, it's not normal or not normal yet. So this is sort of sword of Damocles hanging above Holland and actually forecasting what is going to happen. And more rules that it says somewhere that it's the autonomy, it's real science fiction, maximum in energy. It actually creates a maximum of energy. Those things are still important to me. I started my career in a very conventional yet state-of-the-art building way, which is assisting building state-of-the-art office buildings, very modern for that time. This is 85 or something. Yes, 85. And it was the first building in Europe with this fully wrapped glass skin around the building, and a building which is otherwise also quite radical. This was the other one I made it together with this elder architect, Peter Gerson. And well, you can see it's radicalizing sort of minimalism. So can you do less than this? Hardly less than this. But still, it's full of innovation. So it's minimal at one side, but the other side, it's full of something else. It was the most energy efficient building at that time in Holland, maybe even more, maybe in Europe. It was really efficient. Fully prefabricated, a glass skin that is transparent, and you see the windows from behind. So this is normal technology now. You see it everywhere, basically. Inside, we had no suspended ceilings. I hate suspended ceilings. We had uplighting, and we had all the installations in these vertical shafts, and we had ventilation that was actually pushing the cold air across the floor, and then it would rise up with the heat of your body and the heat of computers. And that's how it works, because it creates heat and then it refreshes the air. This is a well-known system now, and I think it's often used. But then we decided to do something else, because I didn't want to have this minimalist aesthetic. I want to have something else, but didn't know exactly how to do that. So, together in '88, we lived 1 year in the studio of Theo van Doesburg in Meudon in Paris. And we experimented with how can we bring art and architecture together. And as Sandra said, on a digital platform. But here, look at where I was, an XIZ structure for a house. Would be nice, but still this minimalist approach. And that's her work, which uses actually computer sketching, a free interpretation using the mouse to create 3D models in the computer. So that was quite a revelation, I would say, that you could use computer for intuitive acts instead of rational acts. I was and still am the rational person. She is more the one who's looking for surprises, for new things. I'm also looking for new things, but based on rationality. So we wanted to bring this together. The first attempts were not very successful, I think, because it's still two separate realms. You have art and you have a building. So how do you bring it together? That was the real question. So it's not a computing question. It's not something that has to do with technology, really. It has to do with what are you heading for? What are you aiming at? At the same time, not exactly same time, 2 years later, we had this workshop, sketching in space and designing satellites. So I still had this representation of a logical structure, and there's the other representation of more intuitive structures. We wanted to have satellites around the globe and communicating with each other. So we worked together with these cities all over the world. It was 1991, so it's quite a while ago, 35 years almost. The goal was then to create something that surprises ourselves and that's still related on the highest form of technology in that time. So yes, this was a good experiment, and we tried to actually realize that in real life. At the same time, this was the installation, this was the workshop setting, and we also had an exhibition, and we invited Frank Stella, a capital work of Frank Stella, to be in that exposition as an inspiration, because we strongly believed in what he was doing. He went from his black canvases, flat, and then Polish village series. It became shaped, the shaped canvases, and then he was jutting out of the wall, was painting into space. And he used also technology in many ways, actually, fascinations of speed and also a lot of intuitive way of painting. So this is what we wanted with architecture: three-dimensional volumes, like shaped volumes, not shaped canvases, but shaped volumes. We wanted to give shape to a volume in a more intuitive way. We sketched freely using DesignCAD, which was an alternative for AutoCAD, and actually somewhat better than AutoCAD in those days, because you could sketch freely in 3D. So we did many of these sketches and tried to find a logic behind it, try to find a way to get this done. We embedded structures like these in the urban fabric. And, well, this is 1991, but you see this happening. Huh? You see buildings like these embedded in existing urban fabric. We did some of that ourselves as well. I will show you. And it's the contrast. So it's as big contrast as possible. It's radical. Still, it is a conversation. Still, it's a dialogue. Then how to make things? Then the traditional way is, okay, I have a skeleton and I wrap some shape around it. That's not what we wanted. We wanted to have the shape and the structure, the skeleton, actually synchronized. So that was leading us to the idea that we want to have a full synchronization of structure, skin, decoration even. That's all inclusive. We wanted that all-inclusive approach based still on the fusion of art and architecture. The first commission for a larger building we've got was this waste transfer station. That's where we started to, actually it was sold to the client as an envelope around an intuitive sketch, but we didn't have the means to realize that in any way. So we ended up with this building body. That's where we started to think of buildings not like programmatic content, giving a height, not like two-dimensional and it has a height and then you have boxes. No, we wanted to see it as one integral body. And almost literally, although not meant like that, but it has this front which could be seen as the more intelligent head. There was a storage space here. Here's the waste transfer area, and there's a cleaning section in the end. So it also acts more or less as a body. This is the interior where all the transfer of waste to the dumpers is taking place. It's one big space, no columns. So that was the other thing we definitely wanted. We don't want columns. No more columns. Never. That's difficult where you actually are in a society where everything is based on these elements like columns, beams, doors, windows, anything you see from a catalog. We didn't want anything from a catalog. We wanted to make buildings that create their own catalog of things. And then those components, and I come back to that idea of components, of course, those components would be parametric and manageable in many ways and interactive in the end. So here we have a building body as clear as possible, no indication whatsoever of a door or a window. Still, we have a panoramic lookout. Still, we have doors. Here's a door. But it's a cut out of the skin, so it's part of the system. So it's not a door as you buy from a catalog. No, it's a door that is fully synchronized with the body as a whole. It's part of that. It's not a separate thing. It's not an element. It becomes part of the whole. It's a completely different attitude. The interior was almost magical. Not many of you, or none of you, would have experienced this, I think. It was meant as an information-rich environment that was always in motion. The color scheme, well, you should see it in life, of course. The color schemes would change all the time based on user interaction. Here we have a sensor board that can be played by the users, and by pushing here, you bring the light to one side. By pushing there, you bring the light to another side. All that worked fine. So we wrote the algorithms with a small team of computer nerds to do that and to change the data coming. And here it really started that idea of data to manufacturing, but also data to creating atmospheres. We used the data of a weather station on the sea. We imported the data, raw data, then we transposed these data into MIDI signals, and these MIDI signals were actually ruling the light, the fiber lights we had here, all along here. So you see also the interior snow columns, and it follows also the body as a whole, the shape. Here you see a strange structure that's also load-bearing for this undulated floor and twisted floor. It actually creates a loop. You come in here, you go down, you go up here. So it's an endless laminate skate loop inside, referencing to the water cycle, because it's a water pavilion. And this is an intuitive sketch. Not meant to be anything specific, but actually used to have a function inside that structure and inside that experience. So, well, this actually catapulted us, this building, into the international architectural arena. But it was very radical in so many ways that it didn't lead to a lot of new commissions, I have to say, because it was so radically different. The next building we could really test, we did other projects as well, like housing projects, which were a bit more conventional. We tested our ideas on this pavilion. It was first built as a pavilion on the World Expo in 2002. Then it was disassembled and rebuilt at the Technical University in Delft before the building collapsed. And so we had only had this laboratory for ourselves, proto space, for a short period of time. Inside we had this, an arena, a working arena. It's a pentagon. Inside it was fully immersive. At the outside, transparent screens, so we could switch the screens. You could work outside with a group of people, and we could work in 4 different groups to prepare and then go to the center to share and communicate with others. So this was a very good setting, but unfortunately we only could use it for 1 year because of the collapse of the whole faculty. It burned down. So from there on, bigger projects like the cockpit building along a highway in the center of Holland. We also did these buildings here, and you see already the striking difference between a normal, so-called normal building, for us not normal, and a new normal building like this, which is fully designed parametrically and also fired to factory, in close collaboration with the steel manufacturer. So this is the other thing. You're not isolated as a designer. You should team up with the manufacturers from day one, because you have to know the machines. You have to know what the machines can do for you. Sorry, I have to go back. This should run as a video. How can I make it run? Not like that. I have no idea. Maybe I can make it run here. Here. No, then we have to do with this. I don't understand this. Okay. Driving along the acoustic barrier and the pumped up part, which is the showroom, tells you all about the design attitude. Because it transforms from meter to meter. It transforms from something which is convex and concave, yes, convex, concave, then a fault line appears, like in car design. You have these fault lines, these feature lines. And that fault line goes over here, and then another fault line appears here, and actually extends in the other direction. So it's about styling in many ways. So now we have the body, we have the fire to factory process of this whole, I will come back to that later. We have styling. Do we still have art and architecture, is the question, or is this more technology leaning?
I think the video worked when you didn't do the full screen. You can try it again maybe. The video worked when you didn't the full screen. So maybe just press the video, but
yeah, well, we have time.
Full screen.
Yeah, but it should be full screen. Oh, I just had to touch it. I have a touch screen. Yeah. Okay, well, you see the same as I just said. Fault line going up, another fault line taking over, flattening out, another fault line towards the end, etc. So, mind you, the acoustic barrier has 40,000 pieces of steel, and they're all different because of these transitions from concave, convex, fault line, etc. And it has 40,000 nodes, nodal points that are all different. So we could only do this by parametric design, writing a script, a very simple script actually, mapped to each individual of those reference points. We had 10,000 reference points. And then if you can keep counting, you have 40,000 those elements. Okay, so that worked. The other side is closed because the sun comes from here, and these are the BMW garage showrooms and working spaces that you also saw from the top, from the bird's eye view. This is the interior. Interior is full of light. That's what we wanted, full of light coming from the northern, like in the artist studios. You have light from that side, and that is very, very good for exposing anything, and also very good for exposing cars like Lamborghinis, Bentleys, Maseratis over there, and Rolls-Royce. It's a loop, another loop like the water pavilion. Cars start at the other side, basically elevator are brought up, then they drive up here, there's a showroom over here, they drive up here, there's more place there, and they go down and they can go full cycle. Well, this is just to understand what we are doing in relation to what others are doing. So you immediately recognize this as Zaha Hadid, I think. Or Zaha Hadid Architects, this is later. She passed away 7 years before this, I think. So you see seemingly similar approach here. Shapes like this, smooth shapes. But then when you look at how it's made, for me that's quite shocking how much material they use, how not smart this is, how not one system it is. So parts of it is parameterized somehow, but more in a design process and not related to a full synchronization of skin and structure. So it has many layers actually to be able to make it, and it has many exceptions. So one of the things we always say in our architecture, that the exception is the rule. So we're talking about rules, strong, simple rules that create complexity. You can also have a bunch of different rules that somehow work together, of course, but then you are more bound to create complicatedness in the end. And you're bound to become more traditional in many ways. So here you see also the layering on top of that steel structure. And there is some relation here, but otherwise it's sort of lost. So we tried to do better for buildings, bigger buildings. This is the cultural center in Budapest, not far from here. So it's easy to go there and have a look. It's a cultural center. It's a renovation of old buildings and a new part embedded in it. So this is exactly what we wanted when we designed the Sculpture City project. You saw those 2 volumes embedded in existing structure, and this is exactly an example of how that could play out. So we used in the design process parametric system for the whole thing, for the roof, for the body, for the whole structure, for the skin enveloping everything, including canopy here, including forward-leaning parts of the building. It was not made on the base of components because the local contractor resisted very much to that idea, and he started welding it, the structure, which is a complete mistake because you have to be very precise. It has to be an assembly. It has to be an assembly that can be taken down, like the pavilion I showed you. That was taken down because it was a dry assembly. Components, dry assembly, and self-building, as they call it. You just connect the elements to each other, and then you have your building. You don't need scaffolding or molds. So that is how it's made. This is the inside. This is how it was meant, this building, a cultural center, gallery spaces, events, etc. So that works very fine. Now it's bought by the government. You know the government in Hungary. It's not the most pleasant one. And mind you, what they do, they have exhibitions on war. I mean, soldiers. Can you imagine that? Government that calls itself the peace party. Okay. I'm not happy with that. I was very happy with this.
Every human being has a basic instinct to help each other out.
The NASA
If a hiker gets lost in the mountains,
the movie The Martian,
people coordinate a
inside
search.
our building.
If an earthquake levels the city,
Good movie, by the way.
people all over the world send emergency supplies. This instinct is found in every culture, without exception.
I guess somebody must have shown this movie.
At around 4:30 a.m., our satellites detected a storm approaching the Ares 3 mission site on Mars. The storm had escalated to severe, and we had no choice but to abort the mission.
Someone gets lost on
But
Mars,
during the evacuation,
has to find a way to survive.
astronaut Mark Watney was killed.
Now that you should do.
I'm entering this log for the record. This is Mark Watney,
I say it until
I'm still alive.
I find interesting.
obviously. I have no way to contact NASA or my crewmates, but even if I could, it would take 4 years for another manned mission to reach me. And I'm in a hab designed to last 31 days. So, in the face of overwhelming odds, I'm left with only one option. I'm gonna have to science the shit out of this.
Did you hear what he was saying? I have to. I have to science the shit out of this. So he has to use technology and the highest form of science actually to bring himself home. I think that is very much how we think about architecture. Use technology of today to do something that maybe not has been done before. Okay, Abu Dhabi, 2014, already 10 years ago, we applied the systemic of our thinking on a tower. So here we have 1,000 different windows. They're all different because of the curves that grow upward. And we have triangular components here that each are different and each have a different angle. And we managed this system in a parametric way, in a very simple way. It's not complex. We had one person actually was dealing with the whole tower. And then we prepared the guidelines for it, and then it was actually made by a local contractor that followed our guidelines. So that worked. So we didn't follow the whole process until the end, and yet it worked, because we prepared it in a way that was inevitable, how to do this, how to actually manage the process. Interior, you see also why we did windows, low windows, higher windows. Higher windows, you look at neighbors. Lower windows, you can look at the street. Windows like here, you can only look like that. So we diverted the view in this way. And that went well with the structure, which is not very strong. I mean, it's very strong, but not very thick. And actually, it's the strongest rotation and other event resisting structure in that city and maybe beyond, because it's triangulated. So here we have the benefit of triangulation, which is also beneficial to the other projects. A triangulated structure is a network. It's stable. If you take out one of those, nothing happens. The forces would go around and it would find their way. If you have a structure with columns and beams, you take out one column, well, you know what happens. The whole thing collapses. So there's a very strong difference. It's not for aesthetical reasons we do this, but it's actually for inclusive reasons, that you have a structural ID that is strong, that you have a parametric component that can adjust to every shape, actually. So it's very flexible and adaptive in that way. And and we avoid adding layers and layers. It has only one detail. So there's one detail which actually includes that, includes the node, and well, maybe it's hard to say where the component stops, maybe halfway here, and it includes everything that is around that node. And then communicates with the neighbors. That's the idea of parametric design. You don't have isolated elements. You have elements named components that look at each other in a parametric system. So one element knows the other in a way. It knows the difference in angles, and you can actually extract all those data and then send it to factories to manufacture the components. So it's just that. So let's focus on that idea of the component. Would there be water somewhere? Maybe drinking water. I can drink from here. Yeah. So, well, you can think in every material that can be CNC produced, basically. So it can be steel, can be glass, can be wood, can even be 3D printing in some forms, although that is very limited in what you can do with it. But anyway, you need to be able to match your data with the data that the machine reads. Yeah? So it has to be a direct match. Not difficult, but you have to know the machine. As simple as that. You have to know the language the machine is speaking. So we produce data. We don't produce drawings, which makes completely sense. And by doing that, you bypass a lot of steps in the whole building process. And ideally, you bypass contractors. Because contractors, they are managers of the whole process, but they don't have any real knowledge of it, especially not of a process like this. So they have to ask others again. So they create all these steps in between, and then you have tender procedures. which are really painful for innovation. Because what you want to do is you want to team up with the experts, climatic experts, structural engineers, everyone that really is doing things, you want to team up from day one. In tender processes, you can't, because you have to select on the market later on in the process. So that's a very big problematic point in building industry. So one structure, one parametric component. Again, structure and the skin and the, what you could see as decoration, but typically is the place where you can place the grippers for the climbing wall. But it's all integrated in one system, and what you also see is the open node. There's no material in the node. So what happens when you build up, it fits very precisely. Still it's closed, although it's an open node, because it's structurally open. And you see the forces coming down here transfer to the skin, so it works together. Structure, skin works together structurally, transfer to the skin, transfers to another beam, transfer to the skin, etc. So until it goes down in all directions. And again, you can easily take out one. And you can build anything. You can take out one, two triangles form a rectangle, so it's inclusive for more traditional geometry as well, but especially very suitable for building complex structures, and for climbers this is ideal. They can design their own climbing wall. We also developed an application, very simple application that the designers, the climbers could draw curves, and then the application creates the triangulation between the curves, and they can set their own challenges. And that's the way how it will work with this system. Well, looking back a little bit, for where did it start? Actually, it didn't start at architecture. It didn't start in the arts, basically. So this is one of the works of Ilona. It's a folded volume, a volume that is based on an intuitive sketch, and also the sketch is then mapped back on the volume. And then we found a way to make it. It's actually here that we invented that idea of components. You see that each of those is different, but all the details are the same. So it's one component that can be fully tweaked to have any shape, to have any amount of corners, actually triangles, quadrangles, etc. And just by assembling it, it forms the whole. And even in such a way that it challenges gravity, like just not touching the earth. So we had all these challenges in one project, very early project, and that actually was leading towards that idea of the building and the building component. This is what we did at Hyperbody 2010, much later, and a fully integrated component that has insulation. It's 30 centimeters thick. It has the thank you. It has the connections, because you have components is one thing, connection between components is the other thing, which is the most relevant in the end. Otherwise, it's an element, like a brick. A brick is not a component. Brick is an element, and you need other materials to bring it together. It's not integrated in the design of the component. In a component, the connection is fully integrated. It's open to styling. We can style in any sense. You can build a complete structure. You can have openings, windows. You can have climatic control devices. So it's floor, it's wall, it's everything. So it's a universal building block, basically, we were thinking of. I still wait for an opportunity to build something like this, using a system like this. It won't be exactly the same, but it would be using similar principles. It should be big enough that you can bear it with two people, right? That you can place it and bring it together. So students can do that, then it's okay. Then everyone can do it. We were experimenting with drones here, so we did many things. This was my goodbye party in university in 2016.
How are they connected?
Exactly, there is, I have to go back actually. It's all foam, and it has a very strong skin, polyurea skin, very strong. So it works together. It works as a skin that takes forces, but inside we glued a piece of wood, a lath actually, that was strong enough to actually hold the screws, to hold it together. Let's see, you can see it here. So we have these parts that fit together and can be tightened together. And then, so it's quite inclusive system. And the gutters you see here is to have the wiring. So here it's wired, this is lights, and here we have a screen inside, etc. So it also includes the necessary wiring of the structure. Interactive stage, even one of those components. When a lecturer would come up the stage, the component would rise and form a lectern. You see, it's in 3 parts and then it goes up, and I can have my laptop there. And when I would leave the stage, it would come down again. One component, one house. You could think of a house like having, how many of these? 8, 10, 8, 10 components, I think, to actually build a house. I called it news, north, east, west, south, because it has a view in all directions. It can be closed as a box, as a sculpture. It can be opened, and then it obviously is a piece of architecture. It's very livable, small house. Not realized yet. When I ask AI to make a render, you get funny things, no? And actually, it drags me back to a world that I don't want. Because when you, in your prompt, when you type in house, you will get a house, no, somehow. But we didn't make a house, actually. So, of course, I shouldn't have done this as a prompt. I shouldn't have mentioned house, because then we have a problem. If you mention in your prompts architecture, you have a problem. So you have to use other words to actually work with AI. So just look at what AI is doing. Well, it's not the same shape, obviously, because now it's straight up here. And it shouldn't. It has windows. I don't want windows. Well, this is some sustainability aspect, probably, like a Euro palette. But it's not correct either, the geometry, that's obvious. It looks like it, but it isn't anything like it, and it actually compromises the whole idea of component. That's my real question for AI. How can you work parametric components and AI? How can you actually bring that together? I think that's a challenge. So I'm ready to discuss that with you. Component-based body chair, we have bodybuilding, body chair. It's fully scalable. We can go small scale, we can go very big scale, very large scale. So you see this is a chair which has not like any other chair. It has legs and a seating. Legs, seating, it's on one system. Open nodes again to make it easier. Linear connections here, so you bolt them together. It can be disassembled. It can be transported easily. So it can be applied to any scale and any decoration. It's adaptive in a way that my body is measured, leg, that part, body part here. It all adapts to the measurement of your own body. So we had an application for that. And you could do it yourself. You have to measure yourself first. And then you have these sliders. I strongly believe in very simple interfaces, that you have sliders to actually adjust some of the parameters, like you do in Grasshopper, but then is an application. And of course, in a more traditional way, you can make other choices as well. So this is for the shape of it. Have an active chair or a more relaxing chair. Then you have materials you can choose. You can choose finishings, many things. Same we can do with in architecture, a larger scale. This is our Dutch entry for our entry for the Dutch pavilion in Dubai, 2020. Well, actually happened only 2021 because of Corona. But maybe just to stop it to show the components again. So this, and where you walk on balustrades, everything is structure, functionality, being balustrade or something to walk on, or a ceiling, or maybe double-skinned if you need climate. But it's an open structure. So we had this building that is 3,000 square meters, one single component. We had 3 interlacing trajectories of water, trajectory, water. We had an energy trajectory, and we had a food trajectory. Water, energy, and foods. These are the main components. Also, I'm sure I will never reach that point of the later part of the lecture, where I will discuss the rules for another normal. But okay, let's continue. Here we are. That's part 2. So this was, now you have an idea of how we started, what we were realizing, what we were heading for, and still are heading for, actually, because nothing is finished and new technologies keep popping up, so we have to look around and see how we can use that, either here or in any other domains like virtual reality or even in space. So the component has these chapters. I only focus now on the Chinese patient, which is the last chapter, and only discuss it briefly, because I think this idea of the Chinese patient, that's a television program. That's in the time we're still watching television, must have been in the 80s, I think. I saw this on television, a Chinese patient declaring his 4 improvements for China. He was declared insane, that's why he was in the psychiatric hospital, but his points make fully sense. Better food, better clothing, probably not like that. Transport by limousine, I think that's very good, because we all want comfort in transport. Actually, we all want automated cars, that self-driving cars, that we can lean backwards and be transported from exactly where you come from to where you want to go. And he wants one big villa park, China. I think that's a good idea, and I'll show you why, and why it would be realizable. So let's look at some of those rules, 12 rules. These are the rules. Ubiquitous everything, and everything is network, digital, high resolution, decentralized, scalable, etc. Inclusive, adaptive, I could add. It's about these subjects I'm discussing. Basic dividend, which is you need means to live, no? And this is based on the idea of Yanis Varoufakis, land right, food, energy, water. That is important. This is hugely important, I think, that we should share responsibility. And I mean shared, I mean citizens, companies, and governments. Robotic production, I already said quite a lot, but I will say a little bit more. Material management, the identification of everything you do. Every component has an ID. Yeah? So, computer has an ID. This has probably an ID in the manufacturing process, but now no longer. But I want everything to have an ID. Even the water that's inside, everything should have an ID. Otherwise, I cannot address it. So everything should be able to communicate to everything, not only in design process, also when it's made. So here, there are just numbers on the chairs, but it should have been an ID, no? That I can address, I can talk to. Because we are living in the age of Internet of Things and people. People communicate with people, things with things, etc. Everything communicates with everyone. That's the idea. That's the idea behind all of these. This is the most adaptive of everything is adaptive, but this is visually adaptive, spatially adaptive. And I hope I can. How much time have I spent? I think half an hour, so I can continue. So let's talk about this one, the dividend. So it's basically basic income I'm talking about, but then the question is, how do you get that income? And I don't have the solution for it, but I think the one idea of Yanis Varoufakis is quite interesting. So looking back, you have philosophers like Russell. He acknowledges the basic income. Martin Luther King, guaranteed income. In whatever way, but a guaranteed income. So no one should be lost in the system. So everyone should have an identity. Yeah? That's the other thing of it. So you need an ID. Not only to vote, but actually to communicate with things and with other people. I'm sure you know this project, Constant New Babylon. Yes or no? Maybe I should have a quick survey. Who knows this project? 1, 2, 3, 4, 5, 6, okay. 10%? Should be more. I think this is a very interesting Dutch painter, but also sculptor and philosopher. He had this New Babylon project, which was based on the idea that everyone has basic income. You are actually free to spend your time in a way you really want, but you still do things. Yeah? It's not that you don't do things. No, you do a lot of things, but not exactly what a robot could do. So he was also looking at a robotization of society. All the work, which is boring, obviously was done by robots. I think that's a situation we are heading for, step by step, slowly. So it's going to happen. Actually, all these things I'm mentioning here are just going to happen in one way or another. The question is more, how do you manage it in your own profession? How do you work with it? So this is Varoufakis. This is what he said. You can read it, but I'm not an expert on banking, but actually it says that there needs to be a public equity depository. If that's national or not, I don't know, but there should be a resource actually created by all those that are economically active, and a part of their activities is put in the deposit. In this way, it would be easy to actually create that amount, that not only those people, the top 0.1%, has the benefit, but everyone has the benefit. So it acknowledges capitalism, but twisted in a way, that in a, I would say, a techno-social way. Possible, very well possible. Land right, I think everyone has a right to land, in a way. It's very much a Dutch situation I'm talking about, but I don't think it would be very different here in Austria. It would be different in a way that you use the land differently, but also I think there is enough land anyway. So if we look, well, you can read these points. We have this problem of livestock. We have too many cows and pigs, etc. We don't need that many because 70% of what we grow on our land is export. It's not for ourselves. Export is okay, but it's a bit out of balance. Then, so we can reduce livestock and we can use the land in a different way. And that makes a lot of sense, because if you look at the land use, this is Holland. Land use, these cows have a lot of space. They actually, if you calculate the average, you have 3 cows per hectare. If you see how people live in Holland, or anywhere basically, it's much higher. So in cities, obviously, it's much higher, but even on countryside, you have new towns and then people live almost 100 people per hectare. Yeah, typical new town. So it's 30 times as dense. So in one aspect may be a good thing, but for social cohesion maybe, but in other aspects it's not a good thing, because you lose the land. And actually we lose the land to cows. So if we would plan our cities like this, it's much like Broadacre City, by the way. Yeah? So you live, the land is the city. I think that's a good idea. I'm not opposed to metropolises at all, but I think a metropolis should be self-sufficient in food production, and it's a digested way of living. It's a cultural way of living, so I'm not opposed to that at all. But it should take care of its own things and not extract everything from the land. And in the other side, in contrast, the land should also do the same, but much more spread out. So we live here actually in one of those houses, and every house has a piece of land big enough to grow anything. Yeah? Well, it's forbidden to have pigs now, but they used to have it. Everyone used to have a pig here, but it's forbidden now. And that makes sense because it's a lot of smell, but the idea is very good. You have a house that's affordable. This is the typical Hungarian house, the pyramid house, the Kádár kocka, as they call it. Kádár was the socialist, I say socialist, not communist, leader of Hungary between end of 50s, I think, and end of 80s, end of 80s, so a long time. In that time, there were 800,000 of these houses built all over the country, spread all over the country. So it's something that is not acknowledged enough, I think, because they did a lot for the people. All the villages were extended, everyone could build a house family members were used to actually build the house. It was a really collective effort based on a very simple plan, very affordable plan. Everyone could afford it, or somehow was supported. In the Netherlands, I worked with this elder architect I was mentioning. We also tried to get something from the ground. Some 100 of these houses were built. Very spacious ground floor level and smaller rooms in the top. Built in a way that was completely new. You see here these things, it's actually sandwich panels stacked here, leaning towards each other. Everything was sandwich panel. Floor, walls, first floor, separating walls, everything was one element, one component. This is also where I sort of developed that idea that it could be done. Then this house also was white at the outside. But then something happened in that neighborhood. People were starting to shoot at the house. I mean, guns, because they didn't accept it. A house should have roof tiles, no? It's like AI, but then the community actually functions as that, to bring it down to normal. So our own normal is not the same as normal in society. So, but we have to keep challenging society and find that other normal that is actually much more efficient and more beneficial. So they had to add roof tiles to that house eventually. Food production, well, it can start locally in your house, your garden, but that's only part of it. It should do the communities should do their share, and the state should do their share. But I think you need these different levels to communicate with each other in a network. You can start here, growing. Well, you already have your refrigerator, but you can have your incubator for thing. We have in Holland, we have this a restaurant with their own food production, the greenhouse. So all vegetables they use are grown here. In 1991, oh, it's gone here, it should say 1991, we also designed, together with an urban designer, we designed City Fruitful, a city that would grow their own food and also export the food and actually focus on more specials, that they had a position in the market. And we were looking at structures like these, which is elevated urban farming, so nothing new, urban farming. All these things exist for a long time already, but it takes a long time before it's embedded. This is a very early example how to embed it, how to grow food on top of your housing schemes, individual patios with growing food on the roof, CO2 production by cars, parking cars, no electric cars yet at that time. And the CO2 was then brought to the urban farming because that's what they need there. So yes, a city of, so this intermediate scale of neighborhoods and cities could very well be made responsible of growing food, generating energy, and one of the later points, creating water as well, because water is a serious problem. Yes, energy production, small scale. You need to charge your cell phone, you can do it like this. This is, I show it because it's one of our later buildings, but a missed opportunity, because it should have been solar cells all over, but the client didn't want that. So that didn't happen. But it would have been ideal, and it can be fully integrated in the architecture. A calculation effort we did in a competition in Qatar. Suppose you have a building, so this was a real competition, an existing building needs to be renovated, and needs to be prepared for the new era, for the future. This is what we were thinking. You have to have urban farming. You need to harvest water to actually generate water. And you need to have energy, a lot of energy, especially in Qatar where you have a lot of cooling needs. So typically in Qatar situation, to cover the cooling needs, you need to wrap the whole building in solar cells as a minimum. Here we can do with the roof, but there you need to wrap it all around. So there we would need a lot of energy. So a rule could very well be, I'm talking about rules still, that a building should actually be obliged to create their own energy, to squeeze their own water from the air and to create food for their own consumption. I don't think that's a bad idea. And typically I think it's going to happen. So water production, all the skills. It's about water security. Huh? So how do you secure that you have clean water? You can do it at any scale. You can use solar cells, condensate, and then you have many liters of water per day, and you can do it on industrial scale as well, as long as you use solar power or otherwise. Already mentioned this, shared responsibility. So we have to acknowledge that we live in a society that's fully networked, internet in this case, but in the view of the 12 rules, all these elements should be networked. So should communicate with each other at all scales. And it's a sort of scale-free network where you have larger hubs and smaller nodes, but not separate from each other. They should communicate bidirectionally. So you give and take. Well, it happens on the internet, but in the infrastructure for water, energy, and also food, it should be the same, I think. So people that actually are active in that field, they need to inform each other and talk to each other, which they do in sectors, but not as a full network these days. Transport, also that I think.
Can I ask you a question?
Yeah.
Responsibility is interesting. My question is, do you have an example how architecture can trigger the feeling of being responsible?
How we as architects can be responsible?
Because responsibilities is not only physical connection, or very often it's a feeling.
Yeah.
And do you think architecture or the built environment can trigger that people feel responsible?
Yeah, I think the obvious answer is by doing it. No? By being responsible and take responsibility instead of being appointed by some form of rule. Yeah, any profession basically. But we are not responsible for everything, so we should be able to team up with people that are experts in their field. We are not experts in energy production. We are not experts in water production or food production. But we should team up with experts. That's the idea. That's the communicative networked idea. And in the end, I think where it comes down to that if you define a component, you have your material properties, but every other property should be included in that component in the end. So does it contribute to energy production or what does it do? How does it perform? So the performative part of the component will become more and more important. And then, as a whole, you have the body that also has a performance. So you can have these identities at different levels, I think, that constantly, well, this is just this bit speculative, but that constantly should send their information and import information and adjust to that, to take their share of the responsibility. It doesn't sound like it does sound like utopia a bit, but it's just doable. So in the end, it's just doing it.
I think it's another interesting point, because you say that you don't say we shall be responsible, you say we are.
Yeah,
So
basically, yes.
is connected to a discussion we had earlier, the role of architect.
Yeah, but I would not emphasize the role of the individual too much, because the role of the companies is much bigger, and the role of the states is probably even bigger. Although companies are taking over states, so maybe companies, yes. I think to address companies, to take their responsibility is the main thing these days. I wouldn't take it too personally, like, for example, I don't grow food at home. So you shouldn't take it too personal, I think. But in the end, you should find a balance between them responsible and you yourself responsible. And if the other one takes responsibility, it's much easier to do it yourself as well. So, and now you see in society, the main trend is that as much as responsibility is actually given to the individual citizens. It becomes more and more a do-it-yourself society, so to say. So everything is... There are many examples of that. That, like IKEA, for example. You have to assemble the thing yourself. So, and actually, you're not paid for that. So more and more of these do-it-yourself and bring that sort of activities to yourself. I'm not sure that's the most obvious thing when talking about responsibility. So I would rather address the companies and then share the dividend with their shareholders. Or like Varoufakis says, and that's quite radical, he says you should only have shares in the company you work for. You shouldn't have shares for just making profits, because that is the wrong message. If you take shares in your own company, then you have also responsibility to bring that company to full bloom, so to say, to make it a successful company. So there are many things there. You can take a very radical stance, of course, but okay. But that's basically what I mean with shared responsibility. It's not only us. It's all these different scales. Well, things are happening. If you look at the difference between going to the Lidl by car and have this parking lot full of cars, do your shopping yourself. You can also have it done and brought to your home, and I think many already do. In Bangkok, where we lived, for example, almost everyone ordered food by companies like this. No one cooks at home in Bangkok. Not in the city. In the outskirts, yes, not in the city. So that, for me, that's an obvious advantage, because you make many less kilometers if you have food delivery. That car makes much less kilometers than you with your own car, and everyone with their own cars. The other level is the communication, of course. So this guy communicates with that one, everyone communicates with the shop, with everything. Of course, these are choices you can make. You're still the owner of your own ID, so you can still make choices, whom to connect to. About autonomous cars, no one really questions this. Well, this is the USA, 35,000 deaths per year. It's considered normal. When an automated car, like this Volvo, accidentally crashes, it's headlines. Although it's very exceptional that it happens. So this is much more safe than this. Still, the one thing we consider normal, and we consider that as risky business, not risky at all. Robotic production, I've already talked a lot about this. Can we localize it as much as possible? Can we have the workspaces as close to the assembly site as possible? So it's in the component and the assembly and the possible future disassembly that I think is the future, and it's happening. Containers with robots producing on site, it's happening. Again, all scales, art production. Ilona looked at the unfinished boogie woogie and said, okay, I can finish this using other technologies in another way, using 3D printing and using the colors to give different depths to that relief. So that made this very interesting piece here. Today we saw something, yesterday we saw a Robert Longo exhibition, and there was one piece, he had this charcoal drawing of Jackson Pollock. So his interpretation of another drawing with other technology. That's similar to this actually, we have this, and we have another interpretation of an unfinished structure. It's about robotics. So, the Web of North Holland, you have all the elements, components. Sorry, you extract all the data. You list them properly, and you send the data to the cutters, the cutting machines. You assemble it again, take it apart, assemble again. It's so simple, actually. It's so simply complex. It's what I could call simplexity. You can build anything. So it's not a specific aesthetic that is leading us to this idea, but more a rational way of thinking and opening up to intuitive and more irrational ways of expressing yourself in architecture. But only in that combination. Just 4 people taking up the parts that are pre-selected in groups. So this part is up here, that part goes up there. You bolt them together and you have your acoustic wall. Similar to the cockpit, you have your node, you have your space holder basically from node to node, another node, all different. You bolt them together, it builds itself. No scaffolding needed, no molds needed. And you can build anything. I think this was on the poster. Similar, all these components, you have nodes, you have components, and you have your structure, and you have your skin, all comprised in that single detail. So I just passed the 1 hour. Let me see if I go quickly because I want to show a few more things, okay? Maybe this is too obvious to show. Food delivery, material management, everything needs to have an ID. And this is the reference that everyone understands. So we are, as a person, one of these. That's how you behave as a person. You adjust to your other person, you have a certain distance. You communicate with your nearest neighbor, mostly. When you walk on the streets, we do exactly the same, swarming. In architecture, I would say it's more like this. It's swarming, still looking at your nearest neighbor, although some look in a different direction, as I see, but still the same, but organized along a curve, like you are organized here with chairs, still flocking, still swarming, but a specific instance of swarming. That's how we organized the reference points of all we did, the curves of the water pavilion, the feature lines of the acoustic barrier. It's all curves or straight lines sometimes that organize the reference points, which become the nodes, which become later the physical node, and which becomes the full structure and the full integrated skin structure. This is a thing I could briefly get to hear sound, but nothing moves. It should move. Okay, this is electric tuk-tuks in Bangkok. There's an application that you can apply for one of those seats. And now I really am stuck here. Close the program, wait for the program to respond now. I should restart the program. It got stuck. So I can continue here. One of the projects we did in Qatar. It's about booking and about what do you book. Actually, when you book a hotel room or another room, the idea was to have a building that can be booked for 1 hour. Then you have a meeting room, or can be booked for a night. Then you have a hotel room, can be booked for a longer stay, and it can be programmed to actually contain all the functions you need in the course of a day. And each of those functions could actually occupy the whole space. So the basic space would be empty, like a room, a classroom or something like that. And if you need a bedroom, then there's a bed. There's a bedroom. So you program it to be a bedroom. But then you have 50 square meter bedroom. So that's quite okay. The same for kitchen, the same for your home cinema or whatever you want to program it. So that was the idea. How can we make much more efficient use of of buildings, and how can we create 24-hour buildings that actually are never empty? Because buildings stand empty for half or two-thirds of the time, no? It's a classroom like this, any room, it's not used. So we can do this much more efficiently by digitization, by identification of each individual component that is active. So it comes down to the fact that there is only a canopy when you need a canopy. So when it's closed, there's no canopy and the building is closed. It comes down to the idea that there is only an acoustic barrier when there is noise. So why would I have a fixed acoustic barrier if there's no train passing or no car passing? It only has to be there when it's needed. So that is one of the holy phrases of new digital technologies. You only do things when needed, as needed, and when, as, and how, I think. So there it is, and then it behaves. So here we're talking about behavioral architecture. It behaves like an elegant screen. So it's not just functional, but if it likes to wave, it can wave a bit. It can behave. Like these interactive wall components can behave. Is it going? No. So I try to activate it again. Some movies are not working. Oh, it's working. So imagine an environment. We're still talking about radical things. So imagine an environment where all your components that constitute architecture are programmable. And can be a closed wall, but can open up or can in any way respond to people. So what you need is sensors and actuators. Nothing else. Sensors, actuators, and a program.
I have a question. What material is
This one is made of stretchable fabric, which is the skin. Interior there's a so-called, it's an invention by Festo. That's this German company that makes the actuators. Actually the muscles, that when you pump up the volume of the muscle, it contracts. So there's in each of those components is one muscle only. And the way it's built up, they call it fin ray, and it's the two exterior skins and connections in between, that if you push at the bottom, then the whole thing curves. It's very efficient. And they made flying penguins, and they made flying this and that. Festo, very interesting company. But they use it commercially for the process industry, for the robotics, for the production lines. We can use it for interiors, like this project of ours for South Korea, a digital pavilion, where people walking around would actually communicate with parts of that structure that has the same capacities, extending and becoming shorter, and then creating openings and closures. Maybe I skip this participator, which is an adaptive. Maybe I should, well, just for the discussion, these are time zones, and I think time zones is in the end old school. No? Why would we have time zones at all? Why don't we have fluidity? Why don't we have continuity? Why don't I have my personal time and have another one, his personal time or her personal time, and we communicate via an interpolation of that? Could be very interesting. So everything, in my opinion, should come down to an identity, communicating with another identity, and not organized with processes that group identities in a way in another group, in another zone. For example, in the acoustic barrier, if we would have created zones that look alike and have another zone with another script, and it would be more complex. So can we can we develop into a world where everything is more high resolution? This is very low resolution at times. The same goes for banking and other things. So I have a few last words on AI, if you allow me. Is that okay? I asked ChatGPT for rules for another normal. I mean, same text as I used, and then I get this. I'm not opposed to all this, not at all, but it doesn't say anything. It's very generic, politically correct. It brings it down to a sort of level that is let's put it, that is looking to the world from the outside, not from the inside. Architecture, as we have developed, is something that grows from the inside, from the component, putting things together, defining the relationship between components. AI does it completely differently. It has large databases, data sets. You have many buildings, thousands of buildings, and then tries to find something generic. That's the opposite way. That is actually looking at the profession from the outside. You get images like these, and you know Matthias Del Campo very well, I suppose, because he's from Vienna. So he's the guru these days. He gives lectures all over. He has images like this, and they're all very nice. Bangkok. He's often in Bangkok. We met him a few times in Bangkok. So here we have sort of elevated highway. He likes rocks, obviously, and bars. You bring it together in an image. This is the real Bangkok. And the real Bangkok is much more real. Here we have the BTS, bikeway, we have all the traffic, the tuk-tuk, the bikers, the train, we have real buildings like these. Very interesting to look at. So it's basically, if you look at science fiction movies, you see Minority Report or Black Runner, it's very much inspired in Bangkok, the way Bangkok operates. So the reality, and that's often the case, the reality to me is realer than anything I have seen by AI-generated images. So that's an observation from my side. Or this, inside the tuk-tuk. This is really crazy. This guy, he asked us where you're from. He said Netherlands. He has the internet radio. He chooses a Dutch channel. Lager channel, and then he plays this terrible song. But that's just amazing. And of course it rains and traffic, a lot of fun. This is weird, no? And here are VIPs. So asking my students, I go very quickly through this, asking my students to generate AI image on the basis of my lectures, and it's about complexity and other things. And this was, and you can quickly read what is in their mind and what's in the prompts. It's not very different from what Matthias Del Campo produces, by the way. This is Zaha Hadid combined with traditional Thai, elevated. This is constant, New Babylon, say, because that's what I showed. The earth is free. This is your connectivity of your head. But then I discovered, actually, this is not AI generated by my student, because he cheated. He just took it from the internet. A Vietnamese guy. But it's hard to know directly, so sometimes you only find out later. Also, their descriptions, I asked them to do descriptions, 200 word descriptions. Half of the entries were clearly ChatGPT, and you can see it, how it's organized and how politically correct is the wording. And it's always like, at the one hand, ta-ta-tam, at the other hand, etc. It's not genuine. A lot of students are really into healthcare and using applications, really into climate responsiveness, and have this stacked slum-like structures. It's very Bangkokian. Others obviously typed in this Belgium architect, what is his name again? It's very similar to it. There's one student that actually was looking at components, but then I found out it's not generated, but actually it's her own project with a small variation through Imagine. So that's interesting to work with students and to find out as an educator, where does it actually come from? And what are the prompts? And this prompt is obviously right, and obviously this is generated. Old school, modern buildings, and actually the old new, I would say, and the new aged, and a sort of new version of history. Very Japanese. I think Porter was half Japanese. This image, I think, is very strong. So you are here, fully confident, bearing your own identity, feeling safe in an environment that is usually considered not safe. I think that's interesting. Because that's how you can use, if everything is identified and you own your own identity. Reliable information, which is represented by many monitors, local, so no big brother, but locally. Last few images. That was the last project we did, called Utopia Dystopia. And we had male students and female students. All the male students went for planetary projects, designing planets. designing space stations, but with a very interesting twist to it, namely having different speeds and different levels of gravity. So if you are in zero gravity environment, you can simulate gravity, as we know on Earth, but you can also play with it. And you can design it. So you can design with gravity, satellites, and everything rotates and sort of avoids each other in the rotation. Quite interesting project. And of course, you could walk outside, probably with magnetic shoes. And these were the portals to the other projects. So you would step into one portal, you would be launched to one of the other projects. For example, this one. This guy designed a planet with deep canyons. Then he populated the project, and you can do this in Blender very quickly. And you just design a few of these towers and you populate the whole planet with these towers. And the canyons, the scary parts that you could fall into, it's like a game. And they designed sort of game. And you could fall into the interior, and then the building could grow from the interior towards the center. And the game-like aspect was like you have to climb the canyon, the inverse of a canyon, so it's a mountain. Climb, and then where there's almost zero gravity, so inside Earth there's zero gravity. Yeah? That's a funny way, a funny piece of knowledge actually. You would think it's very heavy. No, there's no gravity. So you would become lighter and lighter and then fall back into the real world. So a game-like aspect of a design. Another guy, quite similar, standing on a populated planet with many high-rises, falling into the portal, diving into a game with many levels. And the many levels was including like walking on surface, walking on walls, and walking upside down. So if you watch science fiction movies, then these conditions are normal. It's a new normal condition. You can play with gravity because it's a virtual environment. You can do anything. So there's no gravity that actually links me to the ground. You can play with it. And then we had female students, and this is very strange gender gap here. They went for the full sustainability, green towers, nice, but nothing of that, the other darker approach, which usually was taken on by the male students. Very special in a way. Well, you must have seen this one published. It's actually not a student project, but a multi-million-dollar sponsored project by Neri Oxman. She's now married to Bill Ackman, the very Trumpist supporter. I mean, he donated a lot of money. And he has built a laboratory for her, but then she produces this. And that's not much difference, I would say, from my student project. And it's obviously inspired by Herzog de Meuron. This is in Beirut, of all places. It's built. So this is built. This is the render. We saw this, and it's very exclusive, very rich. So this is the 0.1 very rich people. And that happens, that gap between the people who have money, the have-nots, and the haves, is growing and growing, and this is the effect. So architects typically are inspired by this and think, okay, this is us. I'm not so sure we should look at the world in that way. So this is what people do, stacking, and that is typically inspired by the different steps to knowledge, which is in Buddhist societies. And this is balancing, this is careful, and this is not. But it is radical in its own way, but in a careful way. And I end with the lecture with these examples. You must have seen this. Anyone knows who this is? No? No one? It's in Saudi Arabia, and this is going to be built. It's a stacked tower inside another building with a virtual environment projected around, so you can be anywhere, basically. It's like the inside of that game-like project of one of the students. You're inside a completely different world. Stacked platforms, everything is there. You see the scale of it. This is a house for people. Of course, there will be nature, etc. So that is the structure, that is the virtual environment around you, and this is the mukab, which is a cube, 400 meter, 400 meter, 400 meter. It's huge. It has the size of 20 Empire State Buildings, and it's being built. It will be there. So next year or in 2 years, we will go there as a tourist, and we want to see it. No? That's how it works.